acceleration is equal to the time rate of change of velocity. That's how fast your velocity is changing. And we already know velocity is equal to the time rate of change of position, or time rate of change of displacement. These units are meters per second, and these units are going to be how fast your velocity changes in meters per second every second, or meters per second squared. So what does that mean? A meter per second squared. Acceleration is the change in velocity over change in time. And that means you change your speed or your velocity by 1 meter per second every second. So if we start out at 0, after 1 second we're moving about 1 meter per second, or about this fast. After 2 seconds we'd be moving twice as fast, or about 2 meters per second. And so the acceleration of 1 meter per second squared might look something like this. Let's say I'm accelerating in this direction, right? And I'm moving right now at 1 meter per second that way. Let's 1 meter per second. This distance here in 1 second. Okay? So what does that look like? 0, 1. That's 1 meter per second. So you can imagine 1 meter per second, 0 meters per second, 1 meter per second in the opposite direction. That's what 1 meter per second squared looks like. We're very accustomed to gravity, 10 meters per second squared. That means if I drop something in 1 second, it's moving at 10 meters per second. In 2 seconds, it's moving at... And so that looks like this, as opposed to my 1 meter per second squared of 1 meter per second, 0 meters per second, 1 meter per second. So let's say, for instance, you start out at some speed of 10 meters per second in your car. We remember about 2.2. That's about 22 miles an hour, right? But you accelerate in this direction at 2 meters per second squared. How fast are you going after 10 seconds? How fast? So we say, wait, this is your initial velocity, right? And then there's a change in velocity. You're changing at 2 meters per second every second. That's 2 meters per second every second. So in 10 seconds, you change 20 meters per second. So your change in velocity is 20 meters per second in this direction. So if you start at 10 meters per second, you increase by 20 meters per second, your final velocity is going to be 30 meters per second. Now, this is pretty interesting, so I want to graph it. Here is time, and here is my velocity. I start at 10 meters per second, and I finish at 10, 20, 30 meters per second. This goes from 0 seconds to 10 seconds. All right? Now, I start here, I finish at this velocity. So I'm graphing my velocity versus time. And my speed increases. Now, should it be a straight line? Well, let's see. The slope of this line is velocity. The slope is equal to change in y over change in x, which here means change in velocity over change in time. Well, that's my acceleration, right? And I said my acceleration was 2 meters per second squared, right? It's a constant acceleration. This has to have a constant slope. Must be a straight line. Okay, so the slope of this line is equal to my acceleration. I like it. Change in velocity over change in time is the derivative of velocity. Now, what is the displacement? How far am I compared to where I started? Well, let's see. The change in displacement is going to equal the speed times the little bit of time that has gone by. So in the first second, I'm moving at 10 meters per second. I'm going to have gone about 10 meters. And what we see, if we move along here, that the displacement, the amount I've moved, is the area under this curve. Oh, of course, because the displacement is the integral of velocity if velocity is a derivative of the displacement. So this area is equal to the displacement, the change in displacement during that time. And I could just use a trapezoid, 1/2 the length times the average height, right? Or I could take these 2 points, 30 meters per second, 10 meters per second, and say, wait, this is the average speed. The average speed is 20 meters per second, halfway there, and I can see that this area here is the same as that area. Yeah, so my average speed for that period of time, 20 meters per second, I'm moving for 10 seconds. The total displacement during that time is going to be 200. It's going to be that average speed, 20 meters per second, times 10 seconds, cancel my units, I get 200 meters, right? 2 times the length of a football field.